Hello and welcome back. So far in our C programming series, we have looked at data types, we have looked at flow control, we have learned a little bit on functions. If you have missed any of these topics, please do go back to the previous episode. There's good amount of information out there. Uh, and if you are enjoying this series, make sure you subscribe, put some comments down there so that I can answer it. And of course, do like this video. It'll just make this video reach more people and more people would enjoy this episode. So with that, welcome back. We're going to solve a classic beginner problem for today. Do you know what that is? How do I handle lots of similar data without losing my mind? Right? So maybe it is 30 students marks, or maybe it is about 300 sensor readings, or maybe you want to store a word like hello. So if you take the student marks example, creating dozens of variables for each student, calling it score 1, score 2, score 3, it's not only messy, it is impossible to manage at that scale. So C needs a cleaner, more structured way to organize this data. And that's exactly why arrays were invented. So by the end of this episode, you will understand why arrays exist, the rules behind them, 1D, 2D, n-dimensional arrays, and how to loop and search through arrays. And a huge reveal in the end, something very interesting. So let's get into it. Why arrays? So it's kind of a better model for data. So let's look at that. Imagine trying to store marks for 30 students. If you're going to create score 1, score 2, score 3, all the way till score 30, it's already getting ugly. Now imagine 300. It's going to get really unmanageable, unreadable, impossible to loop over. So arrays solve this by grouping all related values together under one name and storing them neatly in memory. So let's look at what an array is in real life. So the textbook definition is simple. A collection of elements of the same type stored in contiguous memory locations is an array. So that is accurate, but still abstract if you have never encountered an array before. A better picture is an egg carton. So you have this cardboard tray with all these small dimples to put eggs into that, right? So you have one name for that. It's called an egg carton. And you can have multiple eggs in that. How do you do that? Multiple identical slots, all next to each other, each holding the same kind of thing. It's all the same. That's exactly how arrays live in memory. So there are three unbreakable rules for an array. It's the same data type. If you try the analogy of an egg tray, you can't put anything else in the egg tray. It has to be an egg. The shape is designed for an egg. You can't start putting an elephant or a giraffe into that. It has to be a small egg that sits very neatly into that. So that's the data type. It's the same data type. Fixed size. The reason it's fixed size is if you design a tray to hold eggs, you know exactly how many of them can be fit into that. So you decide the size once and it cannot change. Your egg tray is the same size. You don't change it every day. I mean, there are ways to do that. We will talk about it. But in general, you can't change the size of your egg tray or the array. Index always begins at 0. So if you have a tray, x by y structure of holes to hold all these eggs, the index, the first position where you can put the first egg, always begins at 0. That element is 0, not 1. It's important to remember. It's for humans, it's pretty logical to think of that as place number 1. But for a computer, it is 0 because remember references from our previous episodes. We talked about passing the address of a memory variable to a function. So similarly, if you're passing the address of the beginning of an array to a function, the first element can be stored right at the beginning. There is no offset. You just start with 0. The next element is by adding the size of the data type, which is adding 1 to that and moving it a little bit. So go back to the egg tray. You can see the first place where you can put the egg is 0. The next place is you increment your index by 1, the size of one egg, and you reach the second position. So the index always begins at 0. So these are rules. 3 unbreakable rules, same data type, fixed size, and index always begins at 0. So for a one-dimensional array, which is basically your first real data structure, you simply declare an array with the number of elements you want to store in square brackets. So one name, 5 values, all neatly packed together. So that's an example you see on the screen out there. Now accessing these values, okay, we compressed the data into an array. But what if I want to access a certain position? If I want to access the third egg in the egg tray, how do I access that? Pretty simple. You just say egg tray square braces position number 2. Remember, the first position is 0, second position is 1, third position is 2. So if you want to access the third egg, you just say egg tray square braces 2. That's the zero based indexing, which basically means 2 holds the third element. Now let's look at looping through an array. Earlier we talked about for loops, while loops, all the different ways of trying to repetitively do a task. So to repetitively retrieve the scores of these 30 students, you just have to put a for loop starting with I is equal to 0. Maybe I is while I is less than 30, keep incrementing I, and you can access scores of I. So every time I is moving by 1. So you start with I is 0, scores of I is the first student. Now if you make I is 1, scores of I is the second student. So you can go all the way till 30. So that's a simple for loop. It will give you all the 30 values from the array. One loop and all values are processed automatically. Without arrays, you would actually need 30 separate print statements. If you had an array of 30 with 30 student scores, you would need 30 separate print statements. Now it's all done through one print statement just by incrementing the index of the array. The same fundamentals can also be applied to a two-dimensional array, where when you look at data like a grid, like the egg tray I talked about. So this is where you have a two-dimensional index. You have one on the x-axis, one on the y-axis. So some data isn't a simple list. Sometimes it's a table, like a spreadsheet or a game board. So rows and columns, that gives us the index of the element that we are trying to retrieve. This is called a two-dimensional array. So in this example that you see on the screen, it is a matrix of 2 by 3, which is 2 rows by 3 columns. You can see the numbers there. And let's say we want the value 8. The number 8 is actually in the second row and first column. So we basically access it by saying matrix of 1 and column 0. That's how 2D arrays work. Pretty simple. It's just that if you haven't gone through the concept earlier, it might be new. But for somebody who's been through C or any other language, it's very straightforward. So now let's look at searching through arrays. Once you have data, the next question is, how do I find something in the list? Again, the simplest approach is linear search. You start at index 0, compare each element, keep going all the way to the end. So your whole loop will end when you find a match. It's a linear simple search. Nothing fancy. We'll talk about other search patterns which are more efficient, faster in different episodes. But let's say you have this array of scores of 30 students and you want to find the score which is 50% or 60%. All you have to do is start at index 0, compare each element through the loop, stop when you find the match. As simple as that. Then here is the big reveal. So strings, they're actually arrays in disguise. Think of that for a moment. A string in C is just an array of characters. There is no such thing as a string in C. You have a character. If you have a sequence of characters all stored in different locations in a linear array, that becomes a string. So in this example that you see on the screen, the character array word holds the text hello in that. So if I wanted to access a particular letter in hello, all I have to do is use the index of that. And there is something a little more interesting. When you declare a word array and initialize it with, let us say, hello or something, the C is actually going to store hello followed by /0, which is a null terminator. I'll tell you why we need the null terminator. The null terminator basically tells us that, okay, the series or the characters that we started storing one after the other has basically come to an end. The final symbol is the null terminator, saying that the string is now complete. It marks the end of the string. So every string function you have ever used, like string length, string copy, string concatenation, compare, everything, all of them, they depend on this null terminator to know when to stop. Otherwise, we said that strings are a sequence of characters, and if you keep on filling characters, it will go on forever. So if I have a function which accepts the beginning index of an array and it is supposed to read the string, how does it know when to stop? It needs some marker to know that, okay, the string has ended. That marker is /0 or the null character. So it's very important. In C, if you have strings, then without the null terminator, there is really no way any of these functions can work. So /0 is most important, and you cannot count /0. Okay, I mean it's not part of the index. Understanding strings becomes much easier once you understand arrays. So just to keep this episode really short, to focus only on arrays, the big takeaways are simple. Arrays are they group similar data into one structure. They are stored in contiguous memory locations. They have a fixed size and they start at index 0. This is the basics of an array. A one-day array can hold lists because you are saying one dimensional. You have elements one after the other after the other. It's just a list. 2D arrays can basically hold tables. It's like a matrix. You have a row ID and you have a column ID. Strings are just arrays with a special ending. Strings are nothing but character arrays but with a special ending. That's all we need to know for now. Arrays are the foundation of structured programming in C. So once you master them, you basically unlock everything that comes next. We'll start going into dynamic structures, pointers, memory manipulation, and a lot more. So more coming up in the next episodes. Just take a look into how 2D arrays, ND arrays work, and then we'll catch up for the next one. So thank you for listening. Stay tuned for episode 5, and please do subscribe if you like the series. Thank you.